Hey, we are back with some more information about earthquakes, and today we're talking about earthquake hazards. The number one most frequent hazard that people think of with an earthquake is just simply seismic shaking. And that's the number one cause of death in an earthquake, is building collapse, caused by the shaking of the surface of Earth. But that's not the only hazard that comes with earthquakes. Some of the other hazards include things like liquefaction, which is really awesome. You get this happening when there's saturated soil, so dirt mixed with some water. And during the earthquake, the water in the sediment almost acts like a buffer, a spacer. So the sediment, when it's shaking with an earthquake, can actually move around each other and flow almost like water. So liquefaction is when wet soil acts like water. That means things that are heavy can sink in. And it also means things that are lighter actually float to the surface. Maybe like partially emptied containers that are supposed to hold gas under a gas station. If they're mostly full of air, they could float right to the surface. Other hazards might be landslides or mud flows. A landslide is just tumbling rocks, most of the time on a hillside, and they're just loosely sitting on one another. And during an earthquake, when there's a lot of ground shaking, they tumble down the slope. It's a landslide. A mud flow, on the other hand, is very similar to liquefaction, where you have saturated soil, so you have wet soil, but this time it's on a hill, it's on a slope. So when this vibrating takes place, again, the water acts almost like a barrier, a buffer, and it allows the sediment to flow like water, and since it's on a slope, it creates a mud flow. The last hazard we're going to talk about is a tsunami, which is a gigantic wave, potentially 30 meters high. And these waves out in the open ocean, they might seem very small, very average. But as that wave energy gets closer to shore, the ocean gets much, much shallower. And when the ocean starts to get shallow, the front of the wave slows down because it's friction with the bottom of the ocean. But the back of the wave continues to move very fast. And so what happens is you take all of this water with the front moving slow and the back moving fast, you squish it all together, and that makes it stand very tall. A lot of times, these tsunamis can form when the ocean floor has uplift. So what I mean is we have ocean floor subducting under ocean floor, and the friction between those two plates pulls down on the overlying plate. But eventually, with that stick-slip property of plate movement, the top plate is going to snap back, and it's going to push up the water, which then collapses and creates this big wave. Now that we've talked about some of the hazards, there's ways to actually reduce earthquake risk. One of those ways is called the seismic gap. So this is something we talked about earlier, but it's just kind of predicting where earthquakes are more likely based on where earthquakes have happened most recently. So a very safe place might be somewhere where an earthquake happened in the last decade or two. A place that would not be as safe would be an area where there has not been an earthquake for 300 years. There's also many different ways of building nowadays to make structures that are more safe to earthquakes. One method is using cross braces. So if you think about a house that's under construction, you may have a visual of studs in the walls, so just vertical pieces of wood. Cross braces are just extra material that goes between those to support the roof under any sort of seismic shaking. Another method of reducing risk would be base isolators. And this is in taller buildings, almost think like skyscrapers. And it's just a large chunk of pretty much rubber between the foundation and the building itself. So the idea is that when the foundation moves during an earthquake, the rubber will absorb some of that energy and the building will not shake as much. And the very last one are flexible pipes underground. The second most dangerous thing in an earthquake is actually fire, produced by underground gas lines being broken. If you imagine the gas line into your house during an earthquake, okay, that gas line may break altogether or crack, fracture, something could happen to that gas line, and then your house is filling with natural gas. All it takes is one spark and boom goes the dynamite, and your house explodes in a fireball. Debris lands on your neighbor's houses, and now the whole neighborhood is on fire. Flexible pipes are one way to reduce the risk of fire after an earthquake. It's also a pro tip that if you ever are in an earthquake, make sure to turn the gas off to your house right away. just in case there might be a small leak. And if you happen to be in an earthquake, they tried to come up with a catchy phrase, almost like if you're on fire, we all know you stop, drop, and roll. So if you're ever in an earthquake, they try to remind you to drop, cover, and hold. You drop yourself to the ground so the earthquake doesn't throw you to the ground. You cover the important parts of your body, like your thinking parts, your head, and then you hold that position for the duration of the earthquake, which might last minutes. That's all we have about earthquakes for today. If you have any questions, please make sure to ask. Thanks.